Welcome to our presentation. This is passive location detection using BLE technologies for local population approximation. My name is Andrew, and these are my group mates Brianna, Marco, Sylvan, Nick, and Omar, and we hope you enjoy this presentation. Our sponsoring company is Automated Logic. They deal with building automation systems in buildings. For this particular project, we are building a BLE scanner that detects how many people are in a room so they can figure out if the AC system needs to turn on or not.
Our problem statement is as follows. To develop and test an algorithm to estimate the number of people in a room using BLE or Bluetooth Low Energy receivers without installing any custom software on personal BLE or Bluetooth Low Energy devices. So if we break down the statement, so we will develop an algorithm that will be able to count however many people are in a room using certain technologies that include Bluetooth Low Energy receivers without having individual persons install any type of custom software on their phone to be able to be detected. This is what we mean by passive location detection. This method is preferred over the previously established method that our client uses. They currently wait for CO2 or carbon dioxide levels to rise in a room, and that's how the system knows that it needs to cool down the room. However, by the time that happens, they've come to find out that people are already uncomfortable and they can physically feel a difference in the temperature. With this solution, we will be able to seamlessly change the temperature before people even realize that more people have entered the room.
Bluetooth Low Energy, or BLE, is a power-efficient way of using Bluetooth. Normal Bluetooth is used to share decent-sized data between two different devices. The drawback of using normal Bluetooth is that to transfer decent-sized data, you need a decent amount of power to go along with it. This is where Bluetooth Low Energy comes into play. Not all data sharing or large files or need to have enough power for constant transfer. So most devices that take advantage of BLE are devices that only need to share data periodically or for the initial point of contact. For example, it would be like Fitbit, smartwatches, or monitoring sensors. These devices can go prolonged periods of time before losing their energy. So Bluetooth Low Energy was first integrated with normal Bluetooth in Bluetooth version 4.0 back in 2010. And for every Bluetooth version since then, you could find Bluetooth Low Energy in it. Apple has taken full advantage of this technology with their iBeacons, which companies use to identify customers who are physically nearby.
So in this project, we're going by the Scrum or Agile methodology. We're also working with BLE networking technologies to determine the devices in each room. We're also using the BeagleBones black wireless boards as BLE sensors and Wi-Fi platforms. The BeagleBones work in an embedded Linux system environment. For the BeagleBones discovery and data collection process, we are using JavaScript to control the BeagleBone, and we're also using Java language for the algorithm, which takes so
So for our solution, we basically created a 3-step process that we have set to run every 5 minutes. The first step is the discovery process that uses Node.js to run on the actual BeagleBone devices, and that runs for 90 seconds, collecting data on all the devices that it can contact, namely the device ID and the RSSI value, as well as a timestamp of exactly when it got that data. Once that 90-second discovery process is completed, it goes through a file transfer where it sends the CSV file that it generates from discovery from the BeagleBone to the host machine that's running our Java application. And then once the file is transferred over from every single device, then it'll run our algorithm to determine which room the device is in and output that information to the user. And we've determined this process to be about 75% accurate due to devices that can be between rooms and the variance in the signal strength that different devices put out just due to different manufacturers creating them and using different chips.
For our demo today, we are going to explain to you how our program works. At the very beginning, we would have each BeagleBone representing one room. So in this raw data section, this BBBWD represents one room, and then BBBWC represents a different room. And all this raw data is all from one scan. And then completed data, you can tell we have a mixture of devices in one section. And that's because during that timestamp, it would show how many people would be in that room. So in D, there's 2 people, in C, there is 1 person, in E, there is 6 people, in F, there's 1 person, and in B, there is 2 people.
So in closing, due to some unforeseen circumstances that we encountered while developing the Bluetooth Low Energy Scanner, we were not able to fully meet all of our clients' goals. One of these issues that we ran into early on was that the MAC addresses for these devices that we were running scans for were being randomized whenever we would run a scan, thus not allowing for a creation of a database to store time-specific data regarding these devices. Another issue that we faced was that the BeagleBone Black wireless devices that we were using also did not have the best quality antenna to run our scans properly and thus gather data in a precise enough manner for our purposes. Another observation that we had was that Apple Watches themselves were not being discovered once they were paired with an iPhone. Once they were unpaired, they would immediately show up in our scans. One area that this possibly could help out would be in determining the amount of people in a room, and that the device itself would not be available for scanning, thus not adding more parameters for our algorithm to take into account when determining the amount of people in a room. Due to some of these issues that we encountered early on, the project goals became a lot more ambitious than we originally thought, though we feel our client will be able to take our research and use it for further implementations of this project. And now, if anybody has any questions, we will gladly do our best to try and answer them.